So good morning class. Now today we learn the k nearest neighbor algorithm. It is also known as the KNL algorithm. The KNL algorithm is used for the both classification and regression problem, but it's most widely used in a classification. The KNL algorithm is the training phase just over the data set, and when it gets a new data, then it classifies that data into the category that is what similar to the new data. So on the basis of the similarities, this KNL algorithm form the classes or subgroup and keep the data points in that particular sub. The KNL work by finding the data set distance between the query that and all the example in the data set. So whatever the query you are asked, the KNL algorithm find the distance of your query point to the other element in your data set by counting the distance between the points. Then it's selecting the specific number of example query, then vote for the most frequent label, otherwise overfills the label. In case of regression. So let us take this example, and using this example I would like to explain what is a KNL. So this KNL algorithm, let us start. I have the one data set and I differentiate the data set into 2 points. First is the red circle and the second one is the green square. So this red circle and the green square are well defined output of your machine learning algorithm, and then you want to add one new query to your data set, and you want to find out this blue star is belonging to the red circle or it is belonging to the green square. So on the which basis you can say that this blue star is belonging to the red circle or green square. To find out the class of blue star, let we choose the value of k here. KNL algorithm is the nearest neighbor. We wish to take the root for that. Let I am considering the value of k is equal to t. So keep in mind that you are always select the value of k in a such way that it is always a odd number. We will make a circle with a BS as a center just big as to enclose only the 3 data points on the plane. So when we consider this k equal to t, you can find out that this is a nearest neighbor element to my question, to my query, that blue star is belonging to which class. So all these 3 are belonging to the green circle. So hence I take a decision or I classify this blue star as a green circle. Here another example to elaborate this KNL algorithm. Let us consider I have the one data set. In that data set, I keep in the mark of math subject and the computer science subject and the result of the student. So I have the 5 student results with me, and they have the marks like the 4 in the math and 3 in the computer science, 6 in the math, 6 in the 7 in the computer science, and so on, and their respective results. That is fail, pass, pass, fail, pass. Now let us consider a new student, that is X, come to the picture and say that, sir, I have the score 6 in the math and 8 in computer science, so what will be my result? So to find out his class, is it belonging to the pass class or the fail class, I have to do the one machine learning algorithm. I have to implement some machine learning algorithm. So what I am doing here? So the question is here, the query is here, X, that the student X is having the mark math is equal to 6 and the computer science is equal to 8. If the student is failed or passed. So here we take the value of k is equal to 3. So you can take any value, I already told you that. So you can take value of k is equal to 5, 7, anything. But for simplicity, I am taking this of k is equal to 3 here. And to find out the nearest neighbor. So to find out the nearest neighbor, there are the lots of distance formula used, but Euclidean distance is very popular and it is widely used to find out the distance between the 2 points. So the Euclidean distance is one of the points. Here, the formula to find out the Euclidean distance is under root I equal to 1 to k xi minus yi whole square, where x and y are the 2 points and we want to find out the distance between the 2 points. So there is a formula that xi minus yi. In detail, we can say that distance, Euclidean distance d under root x01 minus xa1 whole square plus x02 minus xa2 whole square. That is, x0 is represent your observed value and xa is your actual value. So how to find out this value? So as the formula is say that Euclidean distance d x01 minus xa1 whole square plus x02 minus xa2 whole square. Let us consider the first numerical. So to explain the numerical, I just use this. So let us consider first the value of x. So x having the value of 6 for mathematics, he got the mark 6 in mathematics. So I putting the math 6 here, and the first element of data set, and he is having the mark 4. So 6 minus 4 whole square. He has 8 marks in computer science and relative point, that is roll number 1 having the mark 3 in the computer science. So I am putting the 3. So 8 minus 3 whole square. So 6 minus 4, that is 2 plus 5, 7. So under root 29. So under root 29 is nothing but 5.38. Okay. So the distance between this point and this point is, you can say that is a 5.38. The next one, that is x, that having the mark 6 in math, and the roll number 2 having the mark 6 in the math. So I am putting it here. Plus he has the 8 mark and he has the 7 mark, so I am putting it here. So 0 square minus 1 square is equal to under root 1 or is equal to 1. So the distance between these 2 points is represented by the 1. Come to the next, 6 minus 7. Why? Because 6 and this 7. And 8 minus 8. So again it is a 1. So distance between these 2 points, you can say that again it is 2 points. Then next 6 minus 5, as this is a mark having the 6 and it has a mark 5. So 6 minus 5 plus 8 minus 5, that is 3 plus 1, that is 3 whole square, 9 plus 1, that is 10. 10 under root 10 the value 3.16. So the value between the distance between these two elements, you can say that is a 3.16. Okay, this is 3.16. And the distance between these 2 points is nothing but the 2. Okay. So as our algorithm is say that KNN, that is a K nearest neighbor. K nearest neighbor. So let us consider my value is x is at putting here, and the one element at the distance of 5.38 is representing the fail. One element that is representing the distance 1, it is representing the pass. Another element that is represented by the 1, it is also pass. One element that is represented the 2.2 distance, that is again pass. And one element that is represented by the 3.16, it is again represented by the fail. This is 5.38, okay, and it is indicating the fail. So, what the value of k is equal to 3. So, we are considering only the 3 nearest neighbor elements. So, as value of 3 is k is equal to 3, so I am selecting this is my neighbor, he is my neighbor, and he is my neighbor. So, all these 3 are my neighbor. All these 3 are my neighbor. Okay. And they are come to the class, that is there are 2 classes, that is a pass and fail. So they are come under the class pass. So obviously my x is also pass. So here I am declaring that the value of x is equal to pass. Okay, so based on this we can declare that the value of x is nothing but the pass, because all his 3 neighbors are pass. So on the basis of KNN algorithm, we can declare that the value of x is also pass. This is one of the numerical example of KNN algorithm. Because 3 out of these 3 are the pass, and 3 is greater than 0. No is belonging to 0. So we can say that the x value is nothing but the pass.